Hello everyone, very good evening to all of you. Happy Sunday. The streaming is all right. Let me just check. All right, I can see myself. All right. I'll give a minute and then we will start, okay? I know Sundays are usually we all feel lazy. In fact, getting to a Monday, Sundays are the ones that I hate the most, at least the evenings. I see someone online. Can you introduce yourself? So I think we will get started just for for the people who are going to watch it recorded. You might be you don't want to skip too many minutes of this video, and then so let me get started because these are bite-sized sessions. So welcome to the class, yet another session. This is session number 11. We are going to do some Pythagorean triples. I hope you're aware of what the Pythagorean theorem is. If you're already aware, then it's going to be easy for you to understand this session. So we're going to have a small session. I'm not going to go into a lot of details, just to give you some insights on how you can easily solve some of the Pythagorean problems using the vertically and crosswise sutra that we have in Vedic mathematics. So introducing myself for those who are new to the series, my name is Anup. I'm a Vedic Maths educator at Unacademy, and I've been teaching doing a lot of sessions on the Unacademy platform, teaching to learners, young learners, helping them understand what Vedic mathematics is, giving some insight and sharing some knowledge of what I learned a couple of years ago. So if you are not familiar with Unacademy, Unacademy is one of the leading online learning enablers for in India today, and there are a number of options that you can choose to experience the content that is there, to help you achieve your goals, whether it's your CBSE goal or whether it's you're part of ICSE. Different streams of learning opportunities are available to help you navigate through your your classes. So be it if you're in the 9th, 10th, 11th, 12th grade, you have access to great content, access to a lot of educators across the country to help you with your learning process. So there is a very new feature recently introduced, in terms of, Unacademy. It's called Unacademy Ask a Doubt. This feature is for anybody to try. You need not be a subscriber to Unacademy. You can still try it. You have a doubt with your homework, go ask Unacademy. You're going to get a response, and this is how you do it. There's some screenshots that I've attached here. There is a feature. You need to sign up on the Unacademy website. You ask a doubt, click on ask a doubt, take a picture of what problem you're trying to get help on. Then that's it, and it's as simple as that. If you want, you can crop a specific section, where you want to really point out. You can choose the subject and then sit tight. You will receive the solution soon. So isn't that great, right? This point in time, right? Doubts are an essential part of your learning process. Okay, so I'm doing a bit of introduction. This is normally how I start the session. The very first 5 to 7 minutes are to give you a background on what an academy is, what are the features, and what value you can get out of this platform. Okay, so that's about Unacademy Ask a Doubt. And of course, if you want to access more, want to get further value of it, there is a subscription that's available for you to choose from, where you get unlimited access to a lot of courses, access to top educators on one single platform, exhaustive coverage of syllabus. You have mentorship and guidance. You have your nice and neat study materials that you can download, print, and then keep it for your reference. Your practice tests, live test series, batch courses, a lot of it happening on the Unacademy Plus subscription. New batches start. These are the prices for the Plus subscription. Applies for 9th, 10th, 11th, 12th. If you're taking that, there's a different pricing, and if you're taking for 10th, 11th, and 12th, there's a slightly different pricing. So start small, and then add on months if you really see value coming out of it. At least the parents can monitor and understand what's happening, and see if there's value out of it. But I'm very sure that you will get value out of it, because there's a lot of thought has been gone into developing this platform by Unacademy. So you should definitely use it. Another subscription is called the Iconic subscription. You have the Plus and you have Iconic. Iconic takes it one step higher, for students who need some personal mentorship. There's live doubt solving, there's weekly report, and there's personalized planning. There's also a parent teacher connect. So that takes it one step higher, and for some learners that need that extra guidance, or where their parents are not able to spend enough time, especially during these times, you should check out the Unacademy Iconic subscription. But no matter what, whether you take Plus or subscription, depends on each student. You ultimately, the goal, everyone reaches the same goal, right? So this is the pricing for the Unacademy Iconic subscription. And then of course you have Creative Corner. That's a separate subscription to started last year. This is not, this is beyond your school syllabus. Creative Corner gives you insight, gives you learning on different skills. That's just not your regular skills, but your regular coursework, but it's about it's about different, maybe your passion, right? Music, Vedic Maths, like the session that you're attending, robotics, coding, negotiation, financial literacy also for young learners, chess, effective communication, debating, public speaking. These are all skills that young learners need to get at an early age. And also each one has a unique talent, right? Someone may be a good storyteller inside them, right? But they have not discovered it yet. And it's very important that these are discovered in the very early ages, and that helps them refine that and polish it as they grow. So that's why Creative Corner is very, very it's very insightful, it's very knowledgeable. So that's a separate subscription. You can use it. You can use my code for a 10% discount. It's my code is Anup YT10. There's a 10% discount this year, so do check it out. And you can download the app, and then find out, try some of these features for yourself. Okay, so that's a big introduction. And let me get to today's topic. Just have a small correction here, apologize. This is from the last session. So we're going to be talking about Pythagorean triples. So just keep the short form triples. Okay, and we will solve this, we will solve some problems, and then let me get to it. Okay, so I hope you know what a Pythagorean theorem is, or essentially, let me draw this triangle here. And if you have not heard of it before, essentially, then this might be just new for you, but that's okay, right? And I hope you all recognize this triangle right here, right? This is a simple triangle. It's a right angle triangle, so that means this is 90 degrees, right? This is 90 degrees. And when I have right angle triangle here, and suppose the sides are 3 and 4, I can deduce this side, right? I can automatically deduce this side. Okay, what essentially this means is 3 squared plus 4 squared is equal to 5 squared. This is always a thumb rule for any right angle triangle, and that follows this Pythagorean theorem. Okay, and there's a way it has been derived. I'm not going to get into the details of it. So, and we call this a triple, right? We call this a triple. So I'm going to reference this as a triple, these three numbers as a triple, because they have a unique relationship, right? They have a relationship. If I square 3 squared plus 4 squared, I get 9 plus 16. What do I get? I get 25, right? And this is exactly what is this side as well, right? If I do a 5 square of this, I get 25. So 3 squared plus 5 squared is equal to 5. 3 squared plus 4 squared is equal to 5 squared, right? So essentially this side is the root of 3 squared plus 4 squared. That's my hypotenuse, right? So this is always the case. You can try this. I mean, any other triangle, it can be put in different ways as well, but I will call a triple 3 4 5. Okay, I can call it triple 4 3 5 the way it is laid down. If I put it down this side, if 4 and 3 comes this side, it starts with my base. So let me just take you to the next slide to help you. Yes, so this is how you write a triple. A triple is written as 3 4 5, a base, height, and hypotenuse. What's the base? Okay, gotta be, I apologize here, this should have been so this should have been, let me correct it here. Okay, this should have been written as 4 3 and 5. Okay, the base, the height, and the hypotenuse. See here, 15 8 and 17, right? 15 8 and 17, base, height, and hypotenuse. So this is how I'm going to be representing a triple, and so I will get to the first problem here that I'm going to solve. Suppose you have two triangles like these. Okay, 5, this triple, this is your first triangle and this is your second triangle. Okay, just the sides are different, and you have this angle A. Okay, and you know that this is 90 degrees, right? So this I'm not going to find this, but you know that this is 90 degrees. So all of this will add to 180 degrees. If you're familiar with how triangles are added up, all of this will eventually add up to 90 degrees. But I'm going to show this as A. This is 90 degrees. This is B. This is 90 degrees. Okay, now suppose I have a problem. Okay, and I'm going to add these two triangles together. Okay, this is my first triangle, right? And this is my second triple or second right angle triangle. If the problem is to add this and this is B, this is A, and I will get a resultant triangle right out of this. And see, if I magnify, I have zoomed it down, and if you see I have added this, I get a new triangle, right? I can easily find out the sides of these two triangles by simply adding up these two triples. Now, when I mean adding up these two triples means, if you see a 4, 3, and 5, this is my first triple. And this is my second triple, 15, 8, and 17. See this triangle here. Okay, 15, 8, and 17. This is my second triangle. This is my first triangle. And what I need to do is, essentially, when I'm trying to find out the triple, I have to find the triple of these two together, right? Because this forms another right angle triangle. So I need to find the sides of these. So I'm actually effectively, if I add A, the triple for A and the triple for B together, I will get this triangle, right? So this is what I'm doing. Now you can do this with geometry. You can draw a perpendicular line and figure it out. But I have a very easy way of figuring this out. And don't worry about all these dots here. This is just to show you, how to do a multiplication and subtraction here. So when I add, I will use a method that I've used in Vedic mathematics for multiplication. Okay, so the formula here is, or the pattern I would say, rather in Vedic maths a lot of it is referred by pattern. So the pattern is, see these two lines, I multiply 4 into 15. Okay, I multiply 4 into 15 and I subtract it from 3 into 8. Okay, these two digits. So see these two dots, each of these represent a triple. So 4 into 15 minus 3 into 8, 60 minus 24, right? I get 36. And the second side would be, I do a cross multiplication, right? What is a cross multiplication here? 3 into 15 plus 4 into 8. What do I get? 3 into 15 plus 4 into 8, right? I get 77. And the last one is easy. 5 into 17, 85. So this is my resultant sides of the triangle that I added up together, 36. So what this means is I got 36, 77 and 85. These are the new sides of my triangle that I can easily derive by simply adding this triangle 1 and triangle 2, right? How easy it is, right? It's just as simple as addition and subtraction. And you can check it out. You can try it with different methods and you will end up getting the same. Always, you will obviously, in mathematics, one answer is always correct. Whether you use different methods to do it, you will always get the same answer. You will end up getting the same result, right? Whatever method you do it. But there are problems that you can solve very easily using this. So essentially, when there is an addition problem of two angles is what I'm meaning. When there is an addition problem, now this applies to right angle triangles. When there is an addition problem of two right angle triangles, you can easily solve it by using this pattern out here. All this pattern is what you need to remember, right? This whole stuff here. So first you do a multiplication, vertical multiplication and subtract, right? Multiply vertically first two columns and subtract. Cross multiply the first two columns and then add. So one is a subtract, the other one is an addition, right? And the last one is a simple multiplication itself, 5 into 17. If you use the simple sutra of multiplying two numbers, we use this, right? We use vertically here, we get this. Then we do a cross multiply, 4 plus 6, 8, and then we do this 4. This is how you multiply in Vedic Maths, cross multiplication, vertical multiplication, cross multiplication and adding, vertical multiplication. Okay, so this is what you will get. So that was a very simple and easy method to solve a simple addition of two triangles. That is basically sometimes when you're adding two angles together, finding the resultant sides. You'll find this useful in some geometry problems where you can quickly get the answer. Okay, so let's look at a few more examples now. Similarly, if I have two triples, now I'm representing it in the triple form, 12, 5 and 13 and 3, 4 and 5. So what do? I take, just a second. All right, I hadn't had my charger switched on. Okay, so when I do this, 12 and 3, 36, and you can apply the sutra and then you're going to get the same answer. So effectively it is 12 into 3, 36, right? Minus 5 into 4, 20, which is 16, right? And this one is an addition, right? 5 into 3, 15, plus 12 into 4, 48. And this is simple multiplication, which is 65, 13 into 5. Okay, now keep in mind another thing. See, similar example I have done here, and I've got 75, 100 and 125. You can subtract the common factors out also, but the triple is going to remain the same. See, when you have an angle which is, the angle will always remain the same. okay, but your triple sides can be different, but your angle will remain the same. So suppose this triangle is, you know, 25 times bigger. This is 20, this is x, and this is 25x. All the sides, each side is 25 times equally. The angle will always remain the same, right? Angle is never going to change. So in triples, right, in Pythagorean theorem, one important thing is, if you see that I'm representing it, uh, yeah, so I'm representing it, you know, the triple is for the angle, okay? So whatever angle is there, you know, opposite that. So if you see here, the triple of 45 is 1, 1 and root 2. This is a square of 1 by 1, and this angle is 45, this right triangle. So the triple for this is 1, 1 and root 2. Similarly, the triple for this 60 is 1, the base, the height and the hypotenuse. See, 1, 3, 2. So the triple for this angle will be different, right? For this angle, the base is root 3, the height is 1, the hypotenuse is 2, right? So that is why the triple for this angle is different. So maybe if I was not clear before, the triple for a right angle triangle represents the angle which you are, you know, which you are representing here. It could be any of the angle other than the 90 degrees, right? The other two angles, right? Okay, so that was a simple triple addition. Now you can guess that you can also, okay, so there's something more I have to cover. And there's a very easy problems that you can solve. Let me come back to this, you know, the quadrant angles, and let me do a triple subtraction. First we did a triple addition. Now we're doing a triple subtraction. Okay, suppose you have two angles here, two triangles here. Okay, one is a 4, 3, 5. As you see here, there is a 4, 3 and a 5, and you have another triangle which is 15, 8 and 17. Okay, suppose you want to find out the angle A minus B. Suppose you want to find the angle between them, and you want to find the sides. Basically not finding the angle. We are not solving for angles, we are solving for the sides, okay, of the triangle. So suppose you have two right triangles and you want to find the resultant side. So basically here this becomes a subtraction problem. Okay, so this becomes a subtraction problem. The earlier was an addition problem because you were adding two angles and then finding the resultant side. This becomes a subtraction problem. Okay, so in a subtraction problem, you follow the same pattern. The vertically and crosswise sutra is exactly like before. The only difference is being where we subtracted before. In the addition, we were doing a subtraction here. And here we were doing an addition. It just reverses. That's all. That's the only difference. Okay, and if you're doing that, you are able to quickly get these sides. You're able to quickly derive these two sides, all these sides, okay, without even, you know, doing any other calculation. Just by using these, you're able to derive these two sides. Okay, so I hope this is let me see, clear for you. Let me put it in a reading view. Oops. Yeah, because the image was slightly small there, so that's why I had to. If you look at the, you know, this angle was A for this triangle. Sorry, if I have to use a pen, I need to come back to this. I can't do it on slideshow mode. So let me do it. Let me do another thing. Try to. I'm going to show this image quite clearly for you. That's why I was. So I hope it's clear now. Okay. So what we were doing here is just observe this. Okay. It's important that you understand this concept here. So you have one triangle, right? This one. Okay. This is 5, 3 and 4. Okay. And let me draw the other triangle in a different color. Okay. And you have this triangle here. All right. And that is 15, 17, 8. You have this angle as B, and this whole angle as A. Now if we want to find out this side, obviously it means that this will be A minus B, right? So you need to subtract the two triples. That's all. That's what I'm saying. And then you're trying to find out, what are you trying to find out? You're trying to find out these sides. And by these sides, I'm saying that you're trying to find out OQ, you're trying to find out PQ, and you're trying to find out OP. Okay, these three sides, these green sides, these three greens, this one is what you're trying to find out. Simply by subtracting these two triples, you will get this. And that's how we have done this problem here now. And that is exactly how we have done this problem, by doing a simple subtraction. If you see here, the same pattern that we have done for the same pattern that we did here. What did we do? Here we did a subtraction and an addition, right? And here we did a addition and then subtraction. That's all. So don't worry if you're not able to get a hang of it immediately. It's okay. You can rewind this video and look at it again. Then you might get if you need to practice. See, anything comes with practice. The concepts are reinforced upon practice. Okay, you might get like, 40-50%. After you read through it again, you go through the video again, that might become 70-80%. With practice, you will get to 100% clarity in what this means about, right? What this is all about. Okay. All right. So that was now you can also solve a different kind of problem, and I'll tell you what, this is quite useful. When you are trying to find out, suppose you have a problem, right? Here I have this triangle, okay, PQ, and this triangle this way, 7, 3, and this is basically another right angle triangle. Suppose this point P, I am rotating. This problem is that I'm rotating this point P and I'm making it here through 90 degrees. If I'm rotating it through 90 degrees, if the problem says that find out the coordinates of P star, or whether it's called P star, this is P. Find out the coordinates of this. I can also very easily find out that. Okay, if I know that this is a triple, right? 7, 3, 7 and 3 is given for me, this point. Okay, I'm only given the coordinates of 7 and 3. Okay, and I draw a straight line here, perpendicular. I make this a right triangle. I know that when I calculate what's my hypotenuse will be root 58. How did I get that? 49 plus 9. Root of that is my hypotenuse. Now the problem says that I have to rotate it by 90 degrees. Okay, now one thing that you might want to know is now this becomes an addition problem. No, I have my angle A here, I have 90 degrees here. I need to add 8 plus 90 to get my resultant triangle. Okay, to get my resultant triangle, I will get it in this form now. My resultant triangle would be this. Okay, so you can guess that and I found out the coordinates minus 3 and 7. How did I find out? Now the only one thing is, and I need to tell you this, this represents 90 degrees. This is a triple for 90 degrees. Okay, this is a triple for 90 degrees, and which is what I had wanted to, there is a standard, this is a circle, right? When you look at a circle, let me you're familiar with this, right? This is a quadrant of a circle, a quarter of a circle, right? And 0, 90, 180, 270, right? This is how I can write, each one moves by 90. Okay, on this side. So the quadrant angles, right? These angles can be also represented as a triple. Okay, each of this. Okay, it is just these lines here, that's all. Right, this is a 90 degrees. Okay, so if I have a 90 degrees, there's no base here. All it has is this two sides to it, that's all. Okay, so and I represent it this way, and if it will be helpful to remember this 0, 1, 1, 1, 0, 1, 0 minus 1, 1. these are triples for these angles. So when this will be useful is if I come to this problem, right, I am rotating this by 90 degrees. I can simply apply 0 1 1, that's the triple for 90, and I follow that same pattern for triples addition, and this is what I will get. Okay, suppose you are not for a moment keep the 90 degrees aside. Suppose you have another problem which says that you have a point 52, okay, and you are going to rotate it through an angle of 435. Okay, that means let me increase the size of this. Yeah, so this is the problem here. Okay, suppose I have a 0.52 and I'm going to rotate it through a certain angle, and I know the sides of those angles. Okay, and I know that it's a triple, right? 4 3 and 5, that's a triple. My problem here is try to find out P star here. What's the coordinates of P star? Okay, this becomes an addition problem, right? You have this angle and you have this angle. All you need to find out is a new angle, A plus B. So when you do that, you will get triples addition, right? So how do I do that? 5 and 2, I know this. So we've solved it here, right? So you've solved it here. 5, 2 and root 29. Okay. 5, 2 and this is root 29. This is my first triple. My second triple is 4, 3 and 5. 4, 3 and 5. And I will do a triples addition. Remember with that formula, vertically you multiply, right? I think I have to keep having that formula here. Vertically multiply and subtract. Multiply vertically and subtract. Okay. So I come back to this problem here. I vertically multiply and subtract. So this is 20 minus 6. 5 into 4, 20 minus 2 into 3, 6, 14, right? And then I will cross multiply and add 15 plus 8, 23, right? And I get this one is 5 into 29. Now I have got two different, I've got one hypotenuse as 5, 29, but we want the hypotenuse of the resulting triangle to be equivalent to both these, equivalent to OPC. Here I am having OP here and I am having OP star. So all I'm only doing is, the length is always be the same, right? Suppose you're rotating a point from here to here, when you're rotating it, these two lengths will remain the same. Okay, so I'm expecting that the hypotenuse is 29 only. So when I've got 5 root 29, I will simply divide all of this by 5. If I divide by 5, I get my point as 14 by 5 is 2.8 and 4.6. So this point is basically 2.8, 4.6. Because I've equated the hypotenuse. See, I got root 29. This is root 29, right? So this also is root 29, right? But I got a ratio of it. No, so as I said, it